Quick video to introduce the group project, the team project, and how that's going to work over the next few weeks. So we're introducing that in Unit 10. And for the next few weeks, you're not going to have deliverables associated with the team project for the project itself until the very end. But the way I've structured this is each of your discussions are to be a topic related to the stage of the project that you're going to be at. And that will be the way we check status and make sure that we're moving along. So your participation in the discussions and the project will then be just within your team. How do you know what team you're on? You've been split into teams of 3. And if you go to People over here in Canvas and select on Groups, and there are 4 groups listed, and if you expand it, it'll have the names of your team members. Also, when you go into the discussion boards, the discussion will only be between you and your team. I would encourage you to look at the discussion for this week as soon as possible, because the discussion board's more about getting you guys together and building your team, leveraging your strengths and weaknesses. And I would discourage you from actually putting contact information within the discussion board, but to send it through your email to each other. That way you're not posting that information in a public record. But it is appropriate to discuss how you are going to work together. So if we were to go to the discussion for this week, the discussion is before you do your post, step 1 is to review the project week 1 web page. So there's a separate page for each week associated with the project. And on it, there is the document package for the drawings for that project. Once you've done that, you're going to make an initial post. And in that post, you want to describe strengths you bring to the team. And it can be technical, but people have strengths that may not realize themselves in CAD software, perhaps organizational skills, or you may have teammates that are working full time, and you may have more schedule time to take care of certain tasks. So those tasks are included in the overall project, even though they're not a tangible deliverable. What's the best communication to reach you? Email, text, video, whatever. People have preferences of different communication tools, but your team should derive at something that's going to work for everyone. And your typical schedule availability. It's just to help you guys work together. Your response post is going to be to respond to each one of your team members, which are 2 others. And in your response post, you guys need to discuss, how the team will meet on the project and when, propose which parts you're going to take on or peripheral tasks, and who's going to represent the team as the point person or captain, so to speak, for final submission. For final submission, I would like one person submitting the entire final project, and then it'll be graded manually for each individual. And whoever that person is needs to make one final post stating what the plan is for the team and who's that leader. So the sooner you get involved with this discussion, the more time you have to work out how you're going to communicate. Okay, so if we go to the actual project, the full instructions are here, and broken down in the different phases of the project are listed. This is a suggestion. You don't have to go in this order, but some of the lecture material in the upcoming weeks are going to apply directly to the drawing. So this week, the I'm suggesting that you form your teams and model all the parts that require GD&T and threads, and you'll see why later in the requirements. And then the next week, on week 11, complete all the parts and create preliminary drawing layouts with standard dimensions, omitting the GD&T because we're going to spend 2 weeks of reviewing GD&T. And in week 12, there are tutorials that Allison's prepared to show you how to apply the GD&T to the existing drawings that you've already got dimensioned. And week 13, or unit 13, is to develop assembly drawings and submit the entire package. So that'll take a little coordination on your part because we're looking for a single PDF document package and then separate files for each model to be submitted. For the duration of the project, there'll be additional discussion posts, one each week, that'll help you move these flow along with their topics. The final submission of this project is worth 200 points, but if you include all the discussions, which will be looked at to see how much you participated as an individual in the conversations for the entire project, you add up all 4 of those, and that's another 40 points. This project is the bulk of the score, the largest project in the class, and it's worth more than the final. So the project requirements, individual contributions. Each team member must model one part with a thread. So there's 3 threaded parts in this assembly. Each team member must develop the drawings for at least one part with geometric dimensioning and tolerancing. Now, the complexity of the parts vary quite a bit, and I believe there are 4 parts that require GD&T, and one of them has threads on it. So have discussions in your group about how you want to divide that work up. Perhaps the individual that takes on one of the simpler parts maybe models a grouping of simple parts so they have more parts on their plate. And then each team member needs to develop an exploded assembly drawing, and then in the final discussion you guys will decide which one you'll use for your final submission. The discussion posts will also be starting to prompt you to check each other's work. It's a very common thing. Almost every company requires a second drafter to sign off on a drawing that they checked it before it can go for approval. So this process of peer review is very, very common. And we're going to try to simulate that with the discussion groups. The appropriate documentation for the final project is a solid model of each part for the team. To develop appropriate 2D drawings of each part with dimensions and geometric dimensioning symbols on the ones that require it, which if the sketch doesn't have GD&T, then it's not required. You have to create 3-dimensional exploded assembly, including center lines, with part balloons which identify each part in the bill of materials. And a rendered pictorial view of each part modeled with complete assembly. So you should have a minimum of, I believe, 7 individual drawings for this project. But what we're challenging you with is you're in the driver's seat on layout, sheet size, scale, and checking each other's work on how you meet the checklist. Now, the minimum submissions, again, is a single PDF of the entire project. There'd be multi-pages. All drawings need to be numbered and collated in order in which the working drawing would be. And the size sheet is up to you, but I would encourage you to limit the number of sheet sizes. Typically, you try to have your drawing package be a consistent sheet size, but it's not totally uncommon to have varying sheet sizes. Tonight for this week is to help you with the modeling of the screws. There will be tutorials for each one of the threaded parts posted. They should be posted late at night on 10/26 or 27. But again, you have all 4 weeks to model those parts. I'm suggesting though that you complete those first, and you can each divide up those parts. Now there is a drawing for the screw, which is called the screw, and the part identified as a socket head cap screw is also defined with a drawing. The third threaded part, which is used in more than one location on the assembly, is a flathead screw. And that you'll have to do research to select the proper size and reference the existing drawings for the thread pitch. And it doesn't matter what drive type you put on it, but you need to look up in your resources an appropriate fastener for that component. So there's a little bit of an extra research part of developing that particular component. All right, and again, I got links to the team project PDFs and also to the discussion board here. They're the same assignments, and so the suggested team activities for this week is to review the Machinist Vice data package and coordinate with each other using the prompts in discussion 10, and each member model a screw, either the screw, socket, head, cap screw, or the flathead screw, and each team member model parts that require GD&T, which there are 3. It's well, there's actually 4 because the screw requires GD&T, but there's the vice body, the movable jaw, and the bottom plate. So the bottom plate is the simplest of them all, and so you may consider whoever's assigned to do the bottom plate maybe picks up an additional part or duty. Let's look at the drawing briefly. So these are all the components of the vise. These are the balloons that were referred to in the instruction, but the assembly that you are going to produce is an exploded assembly, so these pieces would be separated from each other, and we'll review that on the week that we cover assembly files. Each member has an individual project to turn in, which is a sectioned assembly, which will be similar to what you see here. That is a separate project, but it's also due on the same day as the team project is due. We have the vice body, the vice jaw, both fairly complex parts with a lot of GD&T. That's the symbols here. So initially, the first week, I would just model the parts. The second week, come in and put all your dimensions on, omitting the GD&T, and you can omit the datums and omit the basic callouts. And then the following week, once you have those all arranged nice and clean, the following week, the lecture will help you walk you through adding that information. We have the handle, which is just a straight bar, pretty easy part. And then we have this main screw, which the handle slides through. And then we have an end cap, which is, there's 2 of them in the assembly. So perhaps the same person that takes on the plate takes on the handle and the cap. But again, that's up to you guys. And the bottom plate is the 4th part with GD&T. Interestingly enough, that's the only part also called out in metric. And then we have the socket head cap screw. And again, for the flathead screw, you need to do the research to find the right fastener, just like you would on a real design team. Again, email me with any questions, but The lecture materials for the unit will be embedded in the project, but I also have a review of one of the lectures from Unit 4, which is on sweeps. The procedure to make a thread is to first make a helix, and then you use the sweep command. So you might want to review that lecture, and the balance of the lecture will be embedded in the project. The study guide is based on Chapter 2. So I believe it's on the section of Chapter 2 that involves sweeps. You've already had a study guide that was on a portion of Chapter 2, which has covered the lofts. Okay, good luck, and let me know if you have problems communicating with your team. And again, if you're not sure who your team members are, you should be introducing each other in the discussion, but you can always go back to this tab called People and look under Groups. And we have 4 teams in the class this semester. Thanks a lot, and I'll see you online.